Myopia, myopia, myopia. Myopia, myopia, myopia. Near distance we can see a far distance we can see a myopia, myopia, myopia. Myopia, myopia, myopia. For that correction we are using. For that correction we are using concave lens, concave lens, concave lens, concave lens. Hypermetropia, 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 hypermetropia. Far distance we can see, near distance we can see. Hypermetropia, 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 hypermetropia. For that correction we are using convex lens, convex lens, convex lens, convex lens. New Cartesian sign convention, new Cartesian sign convention. All distance measured from the pole. Distance positive along the instant trace. Distance negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative. Distance are negative below the principal axis. New Cartesian sign convention, new Cartesian sign convention. All distance measured from the pole. Distance positive along the instant trace. Distance negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative below the principal axis. So we have to take all measurements will be taken from the pole. In the direction of incident positive, opposite to incident is negative. Above the principal axis positive, below the principal axis negative. So as coordinate axis. So we can consider accordingly we can take. Okay. So that is about new Cartesian sign convention. Coming to the dispersion. 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 Splitting a white light into 7 colors. Splitting a white light into 7 colors. Splitting a white light into 7 colors. Say with me, learn with me, sing with me. Dispersion, dispersion, dispersion. Splitting a white light into 7 colors is known as dispersion. Dispersion. Refraction of light takes place by the atmosphere is known as atmospheric refraction. The band of colors is known as spectrum. The phenomena of re-emission of light in all directions with a different intensity. The phenomena of re-emission of light in all directions with a different intensity is known as scattering of light. Scattering of light. Dispersion. Dispersion. Say with me, learn with me, sing with me. Dispersion. 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 Okay, so like that we are discussing. So that is about concepts, 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 concepts. So in the form of songs, concepts in the form of songs, concepts in the form of songs. Whatever I sung the songs, all are concepts related only. So first one we are going to that. First one you are going to that. First, notion I can understand. Definitely, I'm working on it. Definitely, will do it. Okay. So now concepts, whatever concepts I'm discussing. So those are all our whatever the songs just now I sang. All are concepts only. All are concepts only. So first one myopia. Next one hypermetropia. So next one like you can say new Cartesian sign conventions. After that, we discussed about one more. What is that? Dispersion song. So dispersion song. So this all we discussed. All are related to concepts only. All are related to concepts only. So whatever we are discussing, all are related to concepts only. So if you remember this one, so automatically you can get the concepts in easy way. So we can recall the concepts in easy way, so we can remember the concepts in easy way. So definitely it will work out. So like that we are discussing now we will discuss about electric current CBSE grade 10 physics. Electric current CBSE grade 10 physics will discuss. Okay, so now maximum I generally, so from few days onwards, like from starting onwards, I'm keep on explaining the concepts. So now we will discuss about uh, question and answers. So concepts with question and answers I'll discuss. Concepts along with question and answers, because practice session is very very important. So many students are asking continuously. So practice session like that. So now I will discuss about electric current. So question and answers will discuss. Okay. So concepts I already explained. So if you want once check those who are new to the channel. So if you are joining today itself, or you can so you can check once. Okay. So you can check my videos. I already explained electricity chapter. So if you want concept, so in depth, because all concepts related topics only I discussed the entire concept. CBSE grade 10 physics, electricity topic. Now we are going to discuss about completely exclusively about CBSE grade 10 physics, electric current. So question and answers. Question and answers. If it is problems also we'll discuss. Okay. So question and answers we'll discuss. Question and answers we'll discuss. Okay. So we'll see here. As I said in the morning class, so some disturbance is there. That's the reason I couldn't able to conduct due to network issue. Due to net issue, I couldn't able to conduct proper live class. So that's the reason. Sorry for it. Sorry for it. So I'll make sure that it won't happen. At the same time, that is the reason I didn't conduct any live classes from morning to till now. Now only I'm starting. Now only I'm starting. Okay. So now only I'm starting. Thank you, Aditya Singh. Thank you so much. Okay, now what does an electric circuit? What does an electric circuit? Electric circuit is nothing but the flow of continuous C. Electric circuit. Electric circuit is nothing but a closed and continuous path of an electric current is known as a closed and continuous path of an electric current is known as an electric circuit. So what does an electric circuit mean? A closed and continuous path of an electric current is known as electric circuit. So name the SI unit of electric charge. What is the SI unit of electric charge? SI unit of electric charge is coulomb. Okay, so SI unit of current is so Swani, hi. So what is the SI unit of current? So okay, notion. So definitely SI unit of current is ampere. And how much is the charge of an electron? Can a charge less than this value will exist? So normally we know I equal to Q by T. So I'm taking I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. And SI unit of time is second. Okay. So I equal to Q by T. I'm considering. I'm considering here. Okay. So now, so as I said, I equal to Q by T, right? SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. Okay. So how much charge is present? How much is the charge of an electron? Can a charge less than this value exist? Okay. So I'm considering here. Thank you so much. I'm Hero Boss. So thank you so much. Okay, here I'm taking how much is the charge of an electron? Can a charge less than this value exist? So normally on charge of an electron is 1.6 into 10 power minus 19 coulomb. Okay. So on one electron, this much charge is present. So less than this value does not exist. Okay. And uh, how many electrons constitute 1 coulomb of charge? In 1 coulomb of charge, how many electrons are consist? So normally if you are taking 1 coulomb equal to 1 by 1.6 into 10 power minus 19, then you are taking 1 by 1.6 into 10 by 10 into 10 power 19, then you will get 10 by, so 16 into 10 power 19, then you'll get 0.625 into 10 power 19, then you'll get 6.25 into 10 power 18. Okay, so 10 power 18 on one electron. So in 1 coulomb, this many electrons are present in 1 coulomb. So in 1 coulomb, this many electrons are present. So very, very important. In 1 coulomb, so this question is very important. So one more question, as I said, this question will come, and this question also will come. So this value, so especially value you have to remember. This value and that value we have to remember. Okay. So very important, very important. Make sure that you are learning this point. You are learning this point. Next one, define and so you state the relationship between 1 ampere and 1 coulomb. State the relationship between 1 ampere and 1 coulomb. State the relationship between 1 ampere and 1 coulomb. So 1 ampere and 1 coulomb. 1 ampere equal to 1 coulomb per 1 second. So that is nothing but 1 ampere of current is flowing through unit. So 1 ampere, okay. So 1 ampere of current, okay. So define electric and state the relationship between 1 ampere and 1 coulomb. 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 So state the relationship between 1 ampere and 1 ampere and 1 coulomb. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through 1 ampere is defined as. So here you can see 1 ampere is equal to 1 coulomb of charge flowing through unit cross section area per second. Actually, it's electric current. So if you are taking the charges like this, I'm taking like this, I'm considering. So electrons will flow inside of the conductor. Electrons will flow inside of the conductor. Positive, negative, positive, negative, positive, negative, like this. So charges will move. Charges will move. So 1 ampere is defined as 1 ampere is defined as 1 ampere is defined as 1 ampere is defined as. So 1 ampere is defined as 1 ampere. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called okay. So that is nothing but the relationship between 1 ampere and 1 coulomb. So what is an ammeter? How it is connected in circuit? What is an ammeter? What is an ammeter? Ammeter is a device. Ammeter is a device, okay. So which measures the electric current. Ammeter is a device which measures the electric current, okay. So ammeter is a device. So ammeter is a device. Which measures the electric current. Ammeter is a device which measures the electric current. So how you are connecting? So ammeter is a device. Ammeter is a device which measures the electric current. Ammeter is a device. Which measures the electric current. So ammeter is connected in series circuit. So in series combination with the circuit. So next one, what is the SI unit of potential difference? What is the SI unit of potential difference? SI unit of potential difference is volt. SI unit of potential difference is volt. SI unit of potential difference is volt. So define the SI unit of electrical potential. Define the SI unit of electrical potential. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge. So I'm taking the within the conductor. So this is a point A and this is a point B. So positive charge is there and we are doing work. So we are doing work. So 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. 1 volt is defined as 1 coulomb. So 1 joule of work is done. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor is called 1 volt. Okay. So state the relationship between 1 volt and 1 joule. 1 volt equal to 1 joule by 1 coulomb. So that is nothing but That is nothing but so potential difference. So 1 volt is equal to 1 joule of work is done to bring 1 coulomb of charge from one point to another point, from one point to another point. What is meant by resistance of the conductor? What is meant by resistance of the conductor? So resistance of the conductor is nothing but the phenomena of opposing the electric current, the phenomena of opposing the electric current, the phenomena of opposing the electric current, the phenomena of opposing the electric current. So within the conductor, so within the circuit, the phenomena of opposing the electric current. So electric current in the circuit is known as so resistance. Okay. Next one we are considering. So an electric source can supply a charge of 500 coulomb. If the current drawn by device is 25 milliampere, find the time which electric source will discharge it completely. Okay. So this is a question, very easy question only, very easy question only. So by taking the formula I equal to Q by T. So same formula I equal to Q by T, you can take the formula and substitute it. Then you will get the answer. So we'll do it. Okay. This problem will do it. Now we can see. Now we can see. So you can consider here, you can consider an electric source can supply question, an electric an electric electric source electric source can supply can supply can supply a charge, can it supply a charge of 500 coulomb 500 coulomb 500 coulomb. So if the current if the current drawn if the current drawn if the current drawn by if the current drawn by current drawn by a device is current drawn by a device is current drawn by a device is 25 milliampere 25 milliampere. Okay. So find the find the time find the time in which time in which time in which time in which the electric source the electric source the electric source okay, the electric source will be the electric source will be discharged completely, discharge discharged completely discharged completely. Okay. So actually, so this question is given in 2024, okay, CBSE 2024 paper. So this question is given. So this question is given in CBSE 2024. Okay, so you can check once. So this question is very important, very important. That's why I'm explaining this question. Check once. Very simple only, very easy only, very simple and easy question. But identify here a small logic is there, small point is there. If you do that, if you know that, so remaining is very easy. So small point is so here you can observe here one thing. So an electric source can supply charge. So here charge given, charge is 500 charge is 500 coulomb. Okay. So charge is 500 coulomb given, 500 coulomb. Okay. So electric source will be completely okay. So discharge completely. So this is the question. Okay. So now you can see an electric source can supply, here they given 500 coulomb. So 500 coulomb. So that is nothing but the given data. If you are considering the given data, so Q is given how much? 500 coulomb. 500 coulomb. If the current drawn by a device is 25 milliampere, So this is current, this is Q. Okay, so whenever you are reading the question, when you are practicing, whenever you are reading the question, so whenever you are reading the question, so when you are practicing, when you are practicing, okay, so when you are practicing, underline the terms given, underline the terms given. When you are practicing, first underline. So time is, find the time in which the source completely. So we need to find the time. So we have to find the time. Okay, so first you can write I equal to 500, sorry, 25 milliampere. So 25 milliampere is given, 25 milliampere. Okay, so current is 25 25 milliampere, 25 milliampere. So we need to find the time, we need to find the time. So here in this question, you can understand, in this question you can understand. So this is the basic formula. From the basic formula only, they given. So basic formula, so what is that one? I equal to Q by T. So that is simple question. I equal to Q by T. I equal to Q by T. I equal to Q by T. Very, very simple. Very, very simple. So very simple. But so you should not substitute directly. You have to check whether all units are there in one system or not. Whether all units are there in one system or not, you have to check. So whether you have to check whether all units are there in one system or not, you can check. Here I am considering milliampere is given. Here coulomb, okay, fine. But here they given milliampere. 1 milliampere equal to 10 power minus 3 ampere. 1 milliampere equal to 10 power minus 3 ampere. 1 milliampere equal to 10 power minus 3 ampere. 1 milliampere equal to 10 power minus 3 ampere. So now you can consider. So here I am taking current equal to 25 into 10 power minus 3. 25 into 10 power minus 3 equal to 500 by T. So you can cross multiply T equal to 500 by 25 into 10 power minus 3. 10 power minus 3. Then if you take, so T equal to, so you can do it. So 500 into 10 power 3 by 10 power 3 by 25. So how much you'll get? How much you'll get? Check once. How much you'll get? 25 2 ja 20. So then that is seconds. So that is seconds you'll get. Whatever the value you are getting. Okay. So very, very important. Check whether all units are there in one system or not. Whether all units are there in one system or not. Check once. Okay. Check once. Then only we can do it. Then only we can do it. Understood? So is it clear? So do you have any doubts? Do you have any doubt? Check once. So here they given Q equal to 500 coulomb. Okay, I equal to 25 milliampere. So T we have to find out. So 1 milliampere equal 10 power minus 3 ampere. 1 milliampere equal to 10 power minus 3 ampere. So I equal to Q by T. I equal to Q by T. I equal to Q by T. So I equal to 25 into 10 power minus 3. So equal to 500 coulomb by T. So cross multiply 500 by 25 into 10 power minus 3. If it is goes up, so 20 into, we can take 25 to the, okay, so 0 will be there. You can check once. Is it clear? Is it clear? Yes or no? Okay. So that is the answer. T equal to 20 into 10 power 3. T equal to 20 into 10 power 3. T equal to 20 into 10 power 3. So done. So that's enough. So very, very important. Make sure that you are practicing this question. Make sure that you are practicing this question. So very, very important. So check once, check once, check once. So check once answer, check the answer. Check the answer whether you are getting it correct or not. Whether you are getting correct or not. Check once. Okay, so now we are going to the next one. Now we are going to the next one. Here you can see the question is define resistivity of material and give its SI unit. Define resistivity of material and give its SI unit. So what is resistivity? Can anyone say? So I'll give that. I'll explain. Definitely, I'll explain. So as I said when I'm doing this question, when I'm doing this one, this is very important. They will ask for 3 marks question. So make sure that you are practicing. I said. So this is very important. This is very important now. So I'm explaining now. Question is define resistivity. Define resistivity of a material of a material of a material. So full stop. Give its SI unit. Give its SI unit. So find out the SI unit. Find out the SI unit. So this they will ask for 3 marks. So 3 marks question. 3 marks question. Expected 3 marks question. Can anyone say? So what is this one? Define resistivity of a material. Define resistivity of a material. Give its SI unit. Give its SI unit. Can anyone say? Can anyone say? Can anyone say? So what is that one? What is that one? So resistivity is nothing but, so by seeing the formula, we can observe, we can understand. So the formula is, so first one is formula. Normally R equal to rho into L by A. R equal to rho into L by A. Rho is the resistivity. Rho is the resistivity. Rho is the resistivity. So rho equal to RA by L. 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 Right? Yes. So resistivity is nothing but resistance of the material per unit length and unit cross section area. Resistance separately we can take, if you take like this, resistivity per unit length and unit cross section area. Resistivity of the material per unit length and unit cross section area, that is called resistivity. Resistivity. Now you are considering rho equal to SI unit of resistance is ohm, SI unit of length is meter, SI unit of area is meter square. So meter get cancelled. Rho equal to ohm meter. 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 Is it clear? Is it clear? Check once. Check once. So here R equal to rho into L by A. R equal to rho into L by A. Rho equal to RA by L. So rho equal to, so definition is nothing but resistivity of the material per unit length and unit cross section area. So the resistivity of the material, resistivity of the resistance, resistivity is equal to resistance of the material per unit length and unit cross section area. Resistivity is equal to resistance of the material per unit length, and unit cross section area. So that is nothing but resistivity. So SI unit of resistivity. SI unit of resistivity. SI unit of resistivity. SI unit of resistivity. SI unit of resistivity is ohm meter. 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 Understood or not? So they will ask for 3 marks. Very important. Very important. Okay. So make sure that you are learning this one. Next one. List the factors on which resistance of the conductor depends. Write the formula showing the relation of resistance with these factors. So this only same question. List the factors on which resistance of a conductor depends. Write the formula showing the relation between these two factors. Actually, you can see resistance this only. So that question only they are asking again. So resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. Resistance is directly proportional to resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. R is directly proportional to L by A. R is directly proportional to L by A. R equal to rho into L by A. R equal to rho into L by A. So this is the relation. This is the relation. List the factors on which resistance of the y depends. List the factors on which resistance of the y depends. So the resistance depends on length of the conductor. Resistance depends on area of the conductor. Resistance, okay, is directly proportional to L by A. So R equal to rho into L by A. R equal to rho into L by A. So these are the factors. This is the relation. Okay. So now we can go with that one more. So showing the relation completed. Next one. How do you connect an ammeter and voltmeter in an electric circuit? The question is ammeter. How do you connect an ammeter? How do you connect an ammeter and voltmeter in an electric circuit? How do you connect an ammeter and voltmeter in an electric circuit? So that is a question. Ammeter always you have to connect in series combination. Ammeter always you have to connect in series combination. Voltmeter must be connected in parallel combination. Ammeter always must be connected in series combination. Voltmeter must be connected in parallel combination. Write the factors on which resistance of the y depends. Write the factors on which resistance of the y depends. Resistance of the y depends on resistivity. Write the factors on which resistivity. Resistance it is different. So you need to understand here. R is different. R is resistance. R is resistance. Okay, so rho is the resistivity. Rho is the resistivity. Understood or not? Rho is the resistivity. Here you can see. So R is the resistance. Rho is the resistivity. So R depends on length of the conductor. So R resistance. Resistance depends on length of the conductor. So area of the conductor, area of the cross section of the conductor, and it depends on temperature. And also material of the medium. So resistivity depends on temperature and material of the conductor. Resistivity depends on temperature and material of the conductor. So that is about factors on which resistivity depends. Okay, so next one we are going to discuss about one more question. Okay, so previously I already given this question. Same formula. Potential difference is given. Current is given. So we have to find out the resistance. Potential difference is given, current. So now I'm going to discuss about one more point. I'm considering here. One more point. Okay, check once here. Okay. So now, so we can do this problem. We can do this problem. So potential difference is given. Potential difference is given. Potential difference is, so V equal to 6 volts given, and I equal to 30 milliampere. 30 milliampere is given. So we need to find out the resistance. So V equal to IR. R equal to V by A. So what is the R value? Can anyone say? So potential difference is given. Potential difference you can see here. Potential difference is given, current is given. We need to find out R value. How to find out R? Already given the formula. V equal to IR. R equal to V by I. So you can substitute V and you can substitute. Here we need to convert. We need to convert milliampere into ampere. In the previous example I said. In the previous example I said this question. Can anyone say solve this one? How much is the R value? What is the R value? Can anyone say what is the R value? R value. Let me know R value. So here I equal to 30 milliampere. So that is nothing but 30 into 10 power minus 3 ampere. 30 into 10 power minus 3 milliampere. 1 milliampere equal to, so 10 power minus 3 ampere. And 1 microampere equal to 10 power minus 6 ampere. 1 microampere equal to 10 power minus 6. So solve it. How much you'll get it? How much you'll get it? So let me know. What is the answer? What is the answer? What is the answer? So check once. So that is 6 by, we'll get 6,000 by 30. 300 cancel. Now approximately 200 ohm, I hope. Is it correct? Is it correct? So check once here. R equal to, so V is 6, I equal to 30 into 10 power minus 3. Then I am taking 6,000 by 30. So 0 get cancelled, 2. So 200 ohm. Is it correct or not? Let me know. 200. Okay. So what about remaining students? Is it correct answer? Okay. So now next question, very important question. I already said this question is very important. Definitely this question will come for 3 marks. 3 marks in exam, I said. So this is very important question. So try to do this. Try to do this. Try to do this. Okay. So let me know. That is. So distance between terms electric resistance and resistivity. Can anyone say? I already said many times. I explained many times in my videos. So once check the videos. Those are there in the, okay. So in the playlist. So you can check live classes. Live class resistance and resistivity. Many times I said, or distance between resistance and resistivity. Resistivity. Can anyone say this one? Can anyone say this one? So minimum, minimum, minimum of 2 points. I'm expecting from each one, 1 to 2 points minimum I want. Can anyone say? Can anyone say? So I already explained this question many times in my channel. So in my live classes also, I explained this topic. This topic is very important. I said, especially Difference between resistance and resistivity is very, very important, highly important. Check I said, right? So can anyone knows the, can anyone let me know the answer? Let me know the answer. Minimum of 2 points difference. So I'll come back 8:55. 3 more minutes. 3 minutes I'm giving time. 3 minutes because very, very important. 3 marks question. 3 marks question. 3 minutes I'm giving time. 3 minutes time. Okay. So just let me know the answers. Let me know the answers. Those who are able to tell the answers. So let me know in the comment section. We'll check it once. So 3 marks, 3 minutes time. So answers will be given at 9:55. Chalo, start. Carry on. Do it. Okay. So come on. So now we are discussing about resistance and resistivity. Yes or no? Resistance and resistivity. So resistance depends on length of the conductor. Resistance depends on, as I said, resistance depends on length of the conductor. Resistance depends on length of the conductor. Resistance depends on area of the conductor. Resistance depends on temperature. So it depends on temperature. Okay. So resistance depends on temperature. Resistance depends on temperature. Temperature. And fourth one, resistance depends on material. Resistance depends on material. So here resistivity depends on temperature, and resistivity depends on material of the conductor. Okay, so these are the points. Minimum 2 points, I said minimum 2 points. Okay, so I already said minimum 2 points. If you do it, then it is good. So we no need to do more points, minimum at least. Now resistivity depends on material and temperature. Okay, so check once, that's enough. Now we are going to discuss about one more question. So this question is very important. So already we discussed this question. This question may come in exam. Problem. So we are discussing now problem. A copper wire, a copper wire, a copper wire of resistivity, a copper wire of resistivity, a copper wire of resistivity is 1.6 into 10 power minus 8 ohm, 1.6 into 10 power minus 8 ohm meter. So has a cross section, cross section, cross sectional, you can take cross sectional area, cross section area of 20 into 10 power minus 4, 20 into 10 power minus 4 centimeter square. Calculate the length of the wire. Calculate the length of this wire. Length of this wire required to make a 10 ohm coil. So 3 marks question, 3 marks problem. Can you solve it? Anybody? So 3 marks question, very very important. 3 marks question. Okay. So here you can observe, they're asking, say copper wire of resistivity, ohm meter. So I'll wait until 10, 10, 10, 4, 3 minutes. Okay. 10:04 p.m. I will explain. Explanation. Explanation. Explanation at the rate of 10:04. So now 10:02. So 2 more minutes. Can you do it? Try this question and let me know the answer. Try this question and let me know the answer. Okay. Check once. So I'll tell the answer at the end. I'll explain. Okay, check once. What is the answer? So let me know that answer. Okay. Okay. So now 10, 5, one more minute or extra. Now we'll discuss about it. So here you can consider. Now you can consider here. Now you can consider, right? Yes. So a copper wire of resistivity is given. Yes or no? Here I already said whenever you are getting the question, whenever question is there, first you have to underline. So you have to underline. You have to underline. So a copper wire of resistivity is given. Resistivity. This is the resistivity. And so this is the ohm meter only. So ohm meter resistivity. As a cross section is given. Cross section. Okay. So 20. Calculate the length of the wire. So we need to find out the length. Okay. So and ohm also given. Resistance also given. Now you can check once. You write the given data. Write the given data. So resistivity. So given data, given data equal to rho equal to 1.6 into 10 power 8 ohm meter and area of the cross section is given. Area of the cross section is 20 into 10 power minus 4 centimeter square. And so resistance is given. Resistance is given 10 ohm. So we need to find out the length. We need to find out the length of the conductor. We need to find out the length of the conductor. For finding length of the conductor, we know the formula R equal to rho into L by N. R equal to rho into L by. But here you need to understand one thing. Here you need to understand one thing. So they given 20 into 10 power minus 4 centimeter square. Okay, so normally we know 1 meter equal to 100 centimeter. 1 meter equal to 100 centimeter. 1 centimeter equal to 10 power minus 2 meter. 10 power minus 2 meter. So here centimeter square means, so then we can take centimeter square. 1 centimeter square equal to 10 power minus 2 whole square meter square. Then you'll get 10 power minus 4 meter square. That is 1 centimeter square. Right? Correct? Okay, so now then final value area of the cross section is 20 into 10 power minus 4 into 10 power minus 4 meter square. Then we'll get A equal to 20 into 10 power minus 8 meter square. Minus 8 meter square. Is it clear? 20 into 10 power minus 8 meter square. 20 into 10 power 8 minus 8 meter square. So that is the area of the cross section. Now we substitute the values. Value can substitute in this. So R value we know. 10 equal to rho value rho equal to, this is the rho value, 1.6 into 10 power minus 8. And the length we have to find out. Let it be. Area of the cross section is 20 into 10 power minus 8. 10 power minus 8. Now you can check here. Now you can check in this calculation. We can cancel 10 power minus 8. 10 power minus 8 we can cancel. So now length equal to, so 20 into, so 10 by 1.6. Can you do it? How much? Here 200 by 1.6. Then if you do it, L equal to 2000 by 16. Means 10 by 10 you can multiply. 10 by 10. Yes or no? If you do it, you'll get this one. Can I tell? Can you tell me? Can you tell me what is the answer? What is the answer? How much you'll get? What is the answer? 2000 by 16. How much is the answer? 2000 by 16. One 125 centimeter meter. We convert it to meters, right? So answer is 125 meter. Answer is 125 meter is correct. 125 meter length. So like this we have to do it. Check once. So a copper wire of resistivity. Resistivity is given. Cross sectional area is given. Calculate the length of the wire. So this is the ohm. So ohm given. So we need to find out the length. So by using this one, by using this formula conversion, Conversion is very, very important. Conversion is very, very important. Make sure that you are converting. Okay. So after that only it is correct. Otherwise it is wrong. Right? Yes. Mhm. So one more question, same question. So I'll give the same question. Can you find out the resistivity? Can you find out the resistivity? Same question. Okay, try to find out the answer. So now I'm giving. Just check it once. This is the question. Check once. The question is resistance of a metal of length. Here length you got it. So read the question. read the question. I'll explain this question. I'll explain this question after. I'll explain this question after 10, 10, 10, 10, 20. I'll explain. Explanation at the rate of 10:20. Because 4 minutes I'm giving time. 4 minutes I'm giving at least. Okay, explanation. Explanation at the rate of. So already 10:17. So go for 10:20 p.m. 10:20 p.m. I will explain. Can you do it? How much answer? So try it. As I said, as I said, first you have to, underline. First you have to underline what exactly they given. First you have to underline what exactly they given. Okay. First you have to underline what exactly given first. Check once. Let me know the answer. First underline whatever, what is the given data. So what exactly they given in the question. First you have to check once. Okay, so now 10:20 and look into the problem. So check the problem here. Here you can observe. So resistance is given. Resistance is given. Resistance is given. Okay. So resistance of the metal wire. Resistance of the metal wire. So resistance of the metal wire of length is given. And resistance is given. If area of the cross section of wire is given like this. Okay. Calculate the resistivity of the resistivity of the metal. Calculate the resistivity of the metal. So we need to identify this one. So we need to find out the resistivity. We need to find out the resistivity. So length is given. Length is how much? 5 meter. 5 meter, and R is given how much? 100 ohm. And area of the cross section is given. Area of the cross section is equal to 3 into 10 power minus 7 meter square. Calculate the resistivity of the metal. Calculate the resistivity of the metal. Calculate the resistivity of the metal. Okay, so now you are considering here. Now you are considering. So what formula we can use? R equal to rho into L by A. R equal to rho into L by A. So here rho equal to, so from here rho equal to RA by L. RA by L. Rho equal to R is how much? R is 100. R is 100. And area of the cross section is 3 into 10 power minus 7. So by length is how much? 5. Sir, why you substituted directly? So will you not? So here, did you check all the units are there in one system or not? Yes, all systems are there. All units are there in one system. You can check here. So L is meter. So resistance ohm SI unit, and area of the cross section also meter square. So all are there in one system. All are there in one system. You can directly take the formula. You can directly take the formula and substitute and finalize. How much is the answer? How much is the answer? Check. Let me know the answer. 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 Okay. So is it clear? Is it clear? Shall we go to the next one? Shall we go to the next one? Tommy, I can understand. So I understood your concern. So we are going to the 10th electricity topic. Okay. So I'll I'll look into that. So what are you saying? The topic. Okay. Don't worry about it. We will see. Now come to the point. So resistance of metal wire of length 5 meter is 100. So resistance is given. Area of the cross section is given. Calculate the resistivity of the metal. Calculate the resistivity of the metal. You need to find out. Calculate the resistivity of the metal. Okay. So now you can check it once. Now you can check it once. So shall we go? We'll go to the next problem. Next problem. Next question. So that means next question. Next question. Next question. So this is very important. So generally, I in any in my so previous classes also I explained this question. I explained this question. Very important question. We'll look into this topic. A current question is a current of 500 milliampere flows in a series circuit flows in a series circuit containing an electric lamp and a conductor and a conductor and a conductor of 10 ohm when connected to a 6 volts battery 6 volts battery 6 volts battery. Find the resistance find the resistance find the resistance of the electric lamp. So 2 marks question, very very important. For 2 marks this question is very very important. For 2 marks this question is very very important. Try to do it. So explanation at the rate of Hi Arpit, welcome to the class. Yes, Sakib, Najir, correct. Very good. Okay, time for answer. So we'll see now. The answer is, so see, as I said, whenever you are reading the question, first you have to underline. What exactly. You have to understand. You have to understand what exactly the answer. Okay, so you need to understand. So you need to check once whether required data is given in the question or not. Okay. Now you can see. Now you can see. Okay. A current of 500 milliampere is given, flows in series circuit containing here. So check it one. So 500, that is nothing but current, and resistance of the conductor RC when connected to battery, here battery, nothing but potential difference. Find the resistance. We have to find out resistance of L, resistance of electrical lamp, that is nothing but RL. Okay, so that is the data given in the problem, right? Yes, now you can see. So check once, current is how much? 500 milliampere, and resistance RC equal to 10 ohm, and potential difference V equal to 6 volts, and RL we have to find out. RL we have to find out. So we know V equal to IR formula. So V equal to I into RL plus RC, because they given 2. They given 2. Yes or no? They given. So that's why, so I'm substituting here I equal to 6. V equal to 6, I equal to 500 into 10 power minus 3. You can check my previous explanation. 1 milliampere equal to 10 power minus 3 ampere. So I explained this one. Into RL, we have to find out RC is 10. Okay. So like that you have to write first. Like that we have to write. Okay. First you have to underline the given data. Underline the given data and use the formula. Use the formula. Underline the, first you have to underline the given data. Okay, at least you have to identify. You have to identify. You have to identify. You have to identify what exactly they given in the problem. What exactly they given in the problem. At least you have to identify, right? You should understand what exactly they given. After that only we can able to solve the problem. After that only we can able to solve the problem. Without that we can't get it. Without that we can't get it, right? So now we can see current given, resistance of the conductor given, potential difference is given. So resistance of the lamp we need to find out. So 6 equal to, like that we consider RL plus 10 equal to 6 by 500 into 10 power minus 3. 10 power minus 3. Now see this one. See this one. Now see this one. So RL plus 10 equal to, so you can take RL plus 10 equal to 6,000. 6,000 by 500. 6,000 by 500, right? So we can cancel here. We can cancel. So 2020 we can cancel. Next 5 2 ja, then total. Again you can cancel, no problem. So RL equal to RL plus 10 equal to 12. So RL equal to 12 minus 10. Then RL equal to 10 ohm. This is the answer. This is the answer. Is it clear? So check once. If you are getting any concerns, let me know. Oh, sorry. Here, right. 12 minus 10 is 2, right? 2 is answer. That only. So 12 minus 10 is 2 ohm. Sorry for it. So answer is 2 ohm. Is it clear? Do you have any doubts? Do you have any doubts? Hmm. So shall we go to the next one? Next question. Okay. Chalo then. We'll do this problem. The question is how much energy is very important question. How much energy? How much energy is how much energy is given? How much is given to each each coulomb of charge? Each coulomb of charge passing through a battery. Passing through a 6 volts battery. This is the question. So this is a 2 marks question. Can you try it? Can you try to solve it? Can you try to solve it? So answer I will tell. So very simple, very easy one. Try to do it. Try to do it. So remaining students also try to solve it. That's the reason I am giving time. So very simple, very easy, very simple. As I only saying. So I am only saying explanation at the rate of. So 5 minutes is very uh, too extra time, but still I'm giving. So try to solve it. Try to solve. But it's very simple question. Very simple question. If you know the formula, automatically you can do it. Very simple question. Yes, so the answer is, so the answer is, so I'm taking the answer. So here they're asking to find how much energy is given to each coulomb. Each coulomb means Q equal to 1 coulomb. Charge passing through 6 volts battery. So potential difference equal to 6. So we need to find out energy. So energy is nothing but V equal to W by Q. So from this W equal to V into Q. Very simple I said. Very easy. Very easy. So very easy. Very simple question I said. Very easy. Simple question I said, right? So now how much? So W equal to V how much? 6. Q how much? 1. W equal to 6 joule. This is the answer. Simple. Very easy. Very easy. Next question. So next question I'll give. So try to solve the next question. Okay. So be ready for doing next question. 3 marks question. Can you solve? So try to solve it. So explanation will be at the rate of explanation will be at the rate of 11 because now 10:55. So start doing. What is the answer? Let me know. Okay, so come on, be ready. So this question I'm giving, I'm giving as a homework. I'm giving as a homework. So almost, so we went through good practice, nice. So I'll explain once again electricity. So because see, at a time we can't solve it. It will take time. So I'll solve it. We'll try to solve it. This one, try to solve it and do comment answer. So you can do comment the answer. So after the video, after live class also. Okay. So let's see the okay problem. So how many will solve and type in the comment. We'll see. Right, because see, I'm solving that, I'm giving time and solving, so you're getting that's okay, fine. At least one question you can take it as homework. One question you can take it as homework. Okay, so now electric current. Electric current is nothing but rate of flow of charge. Very, very important, as I said. Rate of flow of charge. SI unit of electric current is ampere. SI unit of charge is coulomb. SI unit of, come on. Come on, come on, come on. So discussing only. Okay, so that is about electric current, electric current. I equal to Q by T. I equal to Q by T. I equal to Q by T. The rate of flow of charge. The rate of flow of charge is called electric current. The rate of flow of charge is called electric current. The rate of flow of charge is called electric current. The rate of flow of charge is called electric current. The rate of flow of charge is called electric current. I equal to Q by T. I equal to Q by T. Rate of flow of charge. Rate of flow of charge. I equal to Q by T. So I equal to rate of flow of charge. I said right. I equal to, so I'm considering here I equal to Q by T. So SI unit of current is I equal to Q by T. So SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of charge is coulomb. SI unit of time is second. SI unit of time is second. SI unit of time is second. SI unit of current is SI unit of current is SI unit of current is so SI unit of current is SI unit of current is so SI unit of current is SI unit of current is SI unit of current is so SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. SI unit of ampere. SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. So this is about electric current. Electric current. I equal to Q by T. I equal to Q by T. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of SI unit of SI unit of ampere is current. SI unit of ampere is current. SI unit of charge is coulomb. SI unit of time is second. 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 So the rate of flow of charge. The rate of flow of charge. The rate of flow of charge, 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 rate of flow of charge. The rate of flow of charge is called electric current. The rate of flow of charge is called electric current. I equal to Q by T. 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 Flow of charge through unit cross section area per second is called electric current. I equal to Q by T. I equal to Q by T. So here I am considering here I am considering, here I am considering. So 1 ampere is equal to 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 ampere equal to 1 coulomb per 1 second. 1 ampere is nothing but 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. So that is nothing but so SI unit of electric current. Define SI unit of electric current. If they ask in the exam, 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 define SI unit of electric current. Define SI unit of electric current. Define SI unit of electric current. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. That is nothing but electric current. That is nothing but electric current. Ammeter is the ammeter is a device used to measure the electric current. Ammeter is used to measure the electric current. Ammeter is used to measure the electric current. Ammeter is used to measure the electric current. Voltmeter is used to measure the potential difference. 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 I equal to Q by T. I equal to Q by T. 1 ampere is 1 ampere is equal to 1 ampere is equal to 1 ampere is equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 coulomb per 1 second. So that is about electric current and so SI unit of electric current. Next one. So inside of the conductor, electrons will move. Inside of the conductor, charges 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 will move. Will you say if one electrons will move, if two electrons will move, if three electrons will move, if you say that the current is flowing inside of the conductor? No, right? So current is flowing inside of the conductor. We can't say like that, right? We can't say like that, right? So there are many electrons. There are bunch of electrons there. That is nothing but integral multiple. Integral multiple. Electrons will move like a bench. Integral multiple. Many electrons, many charges. Many charges will move inside of the conductor. Many charges will move inside of the conductor. Many charges will move inside of the conductor. Inside of the conductor. So that's why I'm taking, so that's why I'm considering, so Q equal to plus or minus Ne. Q equal to plus or minus Ne. Number of electrons are passing, number of electrons are passing inside of the conductor. That is about integral multiple, plus or minus Ne. Why sir plus or minus? Why sir plus or minus? Why you are taking plus or minus? What is the reason behind of it? So actually inside of the conductor, positive charges will move, negative charges also will move. Positive charges will move, negative charges also will move. Positive charges will move, negative charges also will move. That is the reason we are taking plus or minus. That is the reason we are taking plus or minus Ne. Plus or minus Ne. So now I am considering here. I equal to Ne by T. 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 So on one electron, how much charge is present in on one electron? So on one electron, if you are taking 1.6 into 10 power minus 19 coulomb. In 1 coulomb, 1 by 1.6 into 10 power minus 19, then you will get 1 by 1.6 into 10 by 10 into 10 power 19. 10 power 19 you will get 10 by 16 into 10 power 19. Then you will get 0.625 into 10 power 19. Then you will get 6.25 into 10 power 18 electrons. In 1 coulomb, this many electrons are present. In 1 coulomb, 6.25 into 10 power 18 electrons are present. In 1 coulomb, 6.25 into 10 power 18 electrons are present. On one electron, so 1.6 into 10 power minus 19 coulomb. And 1 electron, how much charge is present? 1.6 into 10 power minus 19 coulomb. So that is a charge. Is it clear? So next one. Next one. We'll go to the electrical appliances, electrical appliances, electrical appliances, electrical appliances, electrical appliances, electrical electrical appliances, electrical appliances, electrical appliances, electrical appliances, electrical appliances, electrical appliances, electrical appliances. What are those? Cell battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, wire joining, wire crossing, bulb. These are the electrical appliances. So now we are going to discuss about the symbols of electrical appliances. Symbol 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 of electrical appliances. Okay. So now I am considering first one I am taking. So cell, this is the cell, positive terminal, negative terminal. Second one is the battery. One or more cells are connected. Cell, battery. And third one, switch I am taking. Switch, this is the open switch, open switch, and closed switch, open switch and closed switch, open switch and closed switch, open switch and closed switch. And fifth one, resistor. Sixth one, rheostat. Either we can take like this, so anything we can take, that is about rheostat. So rheostat, 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 rheostat. Next one, we are considering cell, battery, open switch, closed switch, resistor, rheostat. And seventh one, ammeter, 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 voltmeter. So ninth one, wire joining, not crossing, wire joining. So wire joining. 10th one, wire crossing. Okay. 11th one, wire joining, wire crossing, wire joining, wire crossing, wire joining, wire crossing, bulb, bulb. Okay, so here you can observe cell, battery, open switch, closed switch. Resistor is a device. Resistor is a device. Resistor is a device. Resistor is a device which opposes the electric current in the circuit. Resistor is a device which opposes the electric current in the circuit. Resistance is the phenomena of opposing the electric current. Resistor is a device which is used to oppose the electric current in the circuit. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. So SI unit of resistance is ohm. Symbol is, so we did. So that is, symbol will be different. So ammeter. So actually rheostat, without changing the voltage source, we can regulate the current. Without changing the voltage source, we can regulate the current. We can regulate the current. And here, so ammeter is a device which measures the electric current. Voltmeter is used to measure the potential difference. So ammeter is used to measure the electric current. Voltmeter is used to measure the potential difference. Wire joining, wire crossing, bulb. Wire joining, wire crossing, bulb. Wire joining, wire crossing, bulb. Wire joining, wire crossing, and bulb. Right. So that is about electrical appliances. That is about electrical appliances. Next, we are going to discuss about electrical circuit. Yes, electrical circuit, a continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of a continuous and closed path of a continuous and closed path of an electric current is known as an electric circuit. Electric circuit, a continuous and closed path of an electric current is known as electrical circuit. Electrical circuit, electrical circuit, electrical circuit, electrical circuit, electrical circuit, electrical circuit. A continuous and closed path of an electric current is known as an electric circuit. An electric circuit, an electric circuit, electric circuit, electric circuit. Now I'm considering here. Now I'm considering. Okay, so electric circuit, electric circuit, electric, electric circuit, electric circuit. So I'm considering the circuit. So I'm taking bulb, sorry, battery here, battery switch. So I'm taking the ammeter. Okay, so bulb, current is passing. So a continuous and closed path of an electric current. A continuous and closed path of an electric current is known as electric circuit. An electric circuit. So first one here, conventional current and electric current. Conventional current. So conventional current and electric circuit. Conventional current and electric current. Conventional current and electric current. Conventional current. Conventional current, first one. Second one is electric current, electric current, electric current, electric current, conventional current and electric current, conventional current and electric current. Conventional current is nothing but generally, so before that, before finding electron, proton, neutron, electron, proton, electron, all these, no, so all electron, proton. So what happened? So they given the statement, the statement is the flow of positive charges, 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 the charges, okay. So flow of positive charges from positive terminal to negative terminal. So flow of positive charges, that is nothing but so current direction from positive terminal to negative terminal, that is nothing but conventional current, conventional current, conventional current. So conventional current. So before that, see, if you change the statement, enter all the experiment, whatever they given, whatever they proved on the statement, so everything will be goes wrong. So that is the reason, instead of changing all those things, so better we can change the statement, that is conventional current. So for our convenient we are using, for our convenient we are using, for convenient, for our convenient, so for our convenient we are using, for our convenient we are using that. So we are using that. So for our convenient we are using that. For our convenient we are using that statement, that is nothing but conventional current, the flow of positive charges, the flow of positive charges, the flow of positive charges, positive terminal to negative terminal, positive terminal to negative terminal is called conventional current. So electric current is nothing but the flow of electrons, the flow of electrons from negative terminal to positive terminal is called electric current. Negative terminal to positive terminal, negative terminal to positive terminal is called electric current. So uh, I can understand. So few members are asking questions. So due to, so if I in middle, yeah, if I clarify those doubts, so again it is an interruption to the class. That's the reason I'm continuing. So it's like a flow. It's like a flow. So I'll take the time and I will answer your questions, all the questions in between. If I am answering all the questions, again it's a problem. That is the reason. So topic we need to continue, right? That's why I'm telling. And those who have any doubt, you can type in the comment section. So Srikar, you have doubt, and Krishna Yadav, you are asking continuously. So regarding the questions, I can understand. So yes, I'm from Hyderabad, right? And one more thing. So I'm teaching physics. So CBSE grade 10 physics right now where it's going on. Right now it's going on. Okay. So that's enough. And 12 o'clock, if it is possible, 12 o'clock I will so take a one class. That is a talk with me, Siva sir, like that. So in that I will ask, I will clarify, I will. So actually general questions are there. That is the reason I'm not no responding in middle. So those you have doubt related to subject, those you have related to those who have doubts related to topic, definitely I will answer it. Definitely you can comment in the section related to topic what I am teaching. What I am teaching. So in that particular topic, if you have any doubts, definitely I will respond to your comments. Okay, I will respond to your comments. So general questions are there. That is the reason. For general questions, I am and okay. So why you may need to interrupt the middle of the class and because these are general questions keep on coming, so who are coming new to the channel, so they have lot many questions. So why like this, what is this, so where it is, like that. So there are so many questions are there. Definitely I agree, I accept it. So it is necessary to answer those questions. That is the reason every day I'm no every day according to the timings. So I'm conducting one class, I'm taking one class, I'm taking one class. I'm taking one class. Talk with Siva sir. Talk with Siva sir. Every day I'm taking. Every day I'm taking. Every day I'm taking. Okay. So every day I'm taking a class. Talk with Siva sir. 12 o'clock. Today I'm taking at 12 o'clock. You can come and join and interact with me. So whatever you have doubts, general doubts related to subject, uh, definitely, definitely, I will answer. I'll answer your questions. I'll answer your questions. Definitely, I will answer your questions and I'll respond to your questions. Okay, those who have those general questions related to subject, definitely I will answer it. Definitely, I will answer it. Definitely, I will answer it. Related to question subject doubts, definitely I will answer it if you type in comment. General questions, because every time we are coming to the channel, new person, new student will be having more number of doubts. Okay, why that? So why this costume? Why the teaching like this? Like that, there are general questions. Yes, I can agree. I can agree. I can agree. So I can agree. So that's the reason I will accept. I will take it all those questions and I will answer to all those questions. So try to join at 12 p.m. Talk with Siva sir. 12 p.m. Talk with Siva sir. So those who have general questions, those who have normal questions, those who want to ask any questions, you can join at that time. So we'll discuss, right? Okay, Arpit, thank you so much. And Nova X first. So thank you so much. And I'm observing. So two people are supporting keep on from starting of this class. Thank you so much for that. And Krishna Yadav, Harsh Kumar, hi. Okay. So everyone, 12 o'clock, talk with Siva sir. Talk with Siva sir. Okay. So we'll see, right? 12 p.m. Talk with Siva sir every day. Anu, hi, hi Anu. So welcome to the class. Like that. So those who are there new to this class, and furious hi. Okay, furious student. Hello, hi. Welcome to the class. Those who are new to the channel, do like, share, and subscribe to Student the Brand. So you'll get great content, good content. I'm teaching physics. I'm teaching physics subject. Okay. So CBSE grade 10 physics I'm teaching right now. So this is the heading CBSE grade 10 physics. Electric current. Electric current. Okay, done. So like yeah, so I understand. I understand. So I can. So I'll do it. So remaining subject, remaining classes, I'm taking time because we are working on a particular goal. So once we reach the goal, then we can do it. Sir, last class you told us that ohmic. Yeah. That only. Curious. Yeah, this only. That chapter only. This one. Electric current. Ohmic conductor, non-ohmic conductor. This only. In the chapter only we'll get it. In the chapter, see like that. See one. If I answer to the honor, if I answer to the one student, remaining students also like continuously it happens. That is the reason. So in middle, why we need to interrupt the class. So let it goes. So certain time I will interact with you all. And anyway, I said so every day 12 p.m. Yes, physics bulletproof for so you can take it as a uh, teaching aid for a physics class. Yeah, it is also bulletproof. Okay. Yes, right. So shall I continue? Because so after half an hour you can join. You can join and discuss with me. You are legend. Thank you, Amol. Oh, thank you. Yeah. Okay. So why are you wearing? Ali, actually, it is a costume. Oh, thank you so much. I don't know the username, but user ID is star. So thank you so much. And Ali, actually, it is a cost teaching aid for me. Like in the part of teaching, I'll every day one design. I will only design and I will only wear for the class purpose. Okay, so it is part and parcel of teaching, right? Nice. So now, shall we continue? Shall we continue? So one more topic is left. So we'll continue this topic then. Salute your hard work, sir. Saurabh. Saurabh, thank you so much. User ID, Saurabh, thank you so much. And do you know Hindi language? Yeah, Toda. Sir, grade 12 physics also. Harsh Kumar, yeah, grade 11 and 12. So it's under construction. The road is under construction. It's going on. Definitely, will work out. I'll work out. That is at night. I am from Hyderabad, so I yes from Hyderabad. Okay, then so let's get into the topic. The topic you can see, I am considering here a conventional current is nothing but flow of positive charges. Electric current is nothing but flow of electrons. So here one more question is there. One more question is there. One more question is there. So charges, positive charges will move from high potential to low potential. Oh, thank you so much. So the positive charges will move from positive terminal to negative terminal. So here. Positive charges will move from positive terminal to negative terminal, whereas electric current, electrons will move from negative terminal to positive terminal, electrons will move from negative terminal to positive terminal. So conventional current and electric current, actually positive charges will move from high potential to low potential. So positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential, whereas electrons will move from low potential to high potential. So charges, positive charges will move from high potential to low potential. Positive charge has high potential, so negative charge has low potential. Okay, low potential. So positive charges will move from high potential to low potential, negative charges will move from low potential to high potential, low potential to high potential. Okay, so this is about conventional current and electric current, conventional current and electric current, conventional current and electric current, conventional current and electric current. I hope it is very clear to you. So next one, so we are going to the one more, that is okay. So conventional current and electric current. Conventional current, electric current is completed. Conventional current and electric current is completed. Now potential difference, potential Potential difference is nothing but, so I'm taking this the conductor, so I'm considering here, so I'm taking this the point A and this the point B. So point A and point B. So we are doing some work. So I'm considering work, that is a positive charge. We are doing some work to bring unit positive charge from one point to another point. We are doing some work to bring unit positive charge from one point to another point. We are doing some work to bring unit positive charge from one point to another point within the conductor, from one point to another point within the conductor, from one point to another point within the conductor. Work done to bring unit positive charge from one point to another point within the conductor, from one point to another point. That is nothing but potential difference. V equal to W by Q. So work done equal to, so here 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge. 1 volt is defined as 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 1 joule of work is done to bring 1 coulomb of charge, 1 coulomb of charge from one point to another point within the conductor, from one point to another point within the conductor is called potential difference. So here SI unit of potential difference is volt, SI unit of work is joule, SI unit of charge is coulomb. Okay, so next one, electrical potential, electrical potential, electrical potential is nothing but, so I'm taking here, so from infinity, so we are doing some work, to bring unit positive charge. From infinity to the required field. So I'm taking this the infinity. So positive charge. So this is the required field. Required field I'm considering, okay. So we are doing some work, W work. So we are doing some work to bring unit positive charge from infinity to the required field. From infinity to the required field is electrical potential. So same formula we are using, V equal to W by Q. V equal to W by Q. 1 volt equal to 1 joule by 1 coulomb. 1 volt equal to 1 joule by 1 coulomb. So that is nothing but a potential difference and electrical potential. Potential difference and electrical potential. So next one more we are going to that. So one more that is about we can go with the Ohm's law. So I'll explain about Ohm's law. Ohm's law. Ohm's law is nothing but Ohm's law is nothing but Ohm's law is nothing but Ohm's law. Ohm's law is nothing but Ohm's law. Ohm's law. So Ohm's law is nothing but the potential difference across a given metallic conductor, the potential difference across a given metallic conductor is directly proportional to current flowing through it. So the potential difference across a given metallic conductor is directly proportional to current flowing through it. So I'm taking here. So this is the resistor I'm taking. So here I'm considering the now ammeter. Next one. 1, 2, 3, 4. Ohm's law is nothing but the potential difference across a given metallic conductor. The potential difference across a given metallic conductor. Here you can see the potential difference across the given metallic conductor. V is directly proportional to I. V equal to IR. V is directly proportional to I. V equal to IR. V is directly proportional to I. V equal to IR. V is directly proportional to I. V equal to IR. V equal to IR. V is directly proportional to I. V equal to IR at constant temperature. The potential difference is directly proportional to the potential difference is directly proportional to current flowing through it at constant temperature. At a constant temperature, the potential difference is directly proportional to the potential difference is directly proportional to current flowing through it. Okay, at a constant temperature. And also physical conditions also we can say the potential difference across the ends of the given metallic conductor. So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V is directly proportional to V equal to IR. V equal to IR. So materials required. What are the materials required? Materials required. Okay, so materials required. First one is so I'm taking 1.5 volts each, 1.5 volts each, 1.5 volts each, 1.5 volts each. Okay, so four cells I'm taking, four cells of 1.5 volts each, 1.5 volts each. And the second one is nichrome wire. Nichrome wire is an alloy of nichrome wire is an alloy nichrome wire Nichrome wire is an alloy of nichrome wire is an alloy of 0.5 meter length. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. and ammeter, ammeter. I'm taking ammeter, and the fourth one is voltmeter, ammeter and voltmeter, and the fifth one is switch. I'm considering switch and switch. So here I'm taking the switch. Okay, switch I'm considering switch. Mm. So here is the switch, and sixth one is connecting wires, connecting wires, connecting wires, connecting wires, connecting wires. Okay. So now these are the material. 4 cells, 1.5 volts each, 1.5 volts, 1.5 volts, 1.5 volts, 1.5 volts. So nichrowire is an alloy of nickel, chromium, manganese, and iron metals. Nichrowire is an alloy of nickel, chromium, manganese, and iron metals. And ammeter, voltmeter, switch, and connecting wires. I'm taking connecting wires. Okay, so procedure. So what is the procedure? Procedure is nothing but, okay. So what is the procedure? First you have to connect one cell you have to connect and note down the reading of ammeter and voltmeter. One cell you have to connect and note down the reading of ammeter and voltmeter. Connect to two cells and again note down the reading of ammeter and voltmeter, and connect 3 cells, and so repeat the process for 3 and 4. Repeat the process for 3 and 4. Repeat the process for 3 and 4 and mention in the tabular form given below. Mention in the tabular form given below. Okay, so I'm considering here. I'm considering here. And I'm considering here. So here number of cells, and ammeter reading, voltmeter reading V by I, that is nothing but R. Serial number 1, 2, 3, 4. 1, 2, 3, 4. Okay. So number of cells, number of cells I'm taking, number of cells I'm considering, and serial number 1 to 4. So after we see, so first you have to connect one cell and note down the reading of ammeter and voltmeter, and connect 2 cells and note down the reading of again ammeter and voltmeter, and repeat the process for 3 and 4. 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 Okay. So same note down, connect and note down the reading of and ammeter and voltmeter, and mention in the tabular form given below. Mention in the tabular form given below. So after drawing, after mentioning, if you draw the graph for VI graph gives, so Ohm's law, so I'm taking V on y-axis, I on x-axis. If it is linear, that is for ohmic conductor. So the substances which obey Ohm's law, those are called ohmic conductor. The substances which does not obey Ohm's law, those are called non-ohmic conductors. So the substances which does not obey, the substances which does not obey Ohm's law, those are called non-ohmic conductors. Okay. So the substances which obey Ohm's law, those are called ohmic conductors. The substances which does not obey Ohm's law, those are called non-ohmic conductors. Okay. So once again, Ohm's law is nothing but the potential difference across the given metallic conductor, across the ends of the given metallic conductor. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I, V equal to IR. Materials require 4 cells, 1.5 volts, 1.5 volts, 1.5 volts each. Like that, 4 cells. Nichrowire is an alloy of nickel, chromium, manganese, and iron metals. Ammeter, voltmeter, switch, connecting wires. Procedure: connect one cell and take the reading of ammeter and voltmeter, and connect to 2 cells and note down the reading of ammeter and voltmeter, and repeat the process for 3 and 4 and mention in the tabular form given below. If you draw the graph for VI values, that is nothing but here. That is nothing but R, we will get R. Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance here. Oh, for ohmic conductor. Ohmic conductor means the substances which obey Ohm's law, those are called ohmic conductor. The substances which does not obey Ohm's law, those are called non-ohmic conductors. Is it clear? So I hope it is very clear. So this is about Ohm's law. And next one. So next one, now we will going to discuss about resistance and resistivity. resistance and resistivity. Okay, so very important. This concept is very important. Ohm's law and resistance and resistivity also very important. Check once. So resistance is directly proportional to resistance. R is directly proportional to length of the conductor. R is inversely proportional to area of the conductor. R is directly proportional to L by A. R equal to rho into L by A. So R is directly proportional to length of the conductor. R is inversely proportional to area of the conductor. R is directly proportional to L by A. R equal to rho into L by A. So rho is the resistivity, RA by L. Rho is the resistivity. Rho is the resistivity. Rho is the resistivity. Rho equal to RA by L. So R is the SI unit of resistance is ohm. SI unit of area is meter square. SI unit of length is meter. So then you will get ohm meter. SI unit of resistivity is ohm meter. Very important. Very important point. So this one they will give in exam. So they will ask about derive or express the SI unit of resistivity and resistance factor depends on resistance. What are the on what factor the resistance will depends. So write the relation and derive the SI unit of resistivity So they will ask about this one. Okay, so this is very important. And one more thing, resistance depends on length of the conductor, resistance depends on area of the conductor, resistance depends on temperature, and resistance depends on material of the conductor. Coming to resistivity depends on temperature, resistivity depends on material of the conductor. So this is about difference between resistance and resistivity. Difference between resistance and resistivity, very important. Even in the previous, if you see the my live classes, so in the before live, so before okay topic, so you can observe there also explained many times. So in that also you can get to know. uh, Isha, after long time, hi, good evening, welcome to the class. So after many, like 1 week or like that, sorry is teaching now. So if temperature increases, resistance also increases. Light and sky. If temperature increases, resistance increases. So it is depends on drift speed. The average speed of an electron is called drift speed. So when the temperature increases, the electrons, the charges will move inside of the conductor. So randomly, so there only collision will takes place between them at the same time between the walls. It keep on increasing the collisions. Then it won't move forward. So then speed will decrease. That is resistance. Resistance will be more. If temperature increases, the resistance also increases. I am right? Am I right? Light and sky. Okay, done. So we'll see. So this is about resistance and resistivity. Resistance and resistivity. I hope it is very clear. So if you have any doubts, let me know. Okay, so I will start talk with Shiva sir. Talk with Shiva sir. We'll discuss about 12 p.m. So now little break. Even I will drink some water. Okay. So I'll take a break. So 10 minutes break now. I'll start exactly 12 p.m. Exactly 12 p.m. Talk with Siva sir. So if you have any queries regarding subject, regarding the classes, regarding any normal discussion, you can come and join at 12 p.m. That is your completely depends on yours, because see, when I'm answering all these question middle of the class, so it deviate from the content, because those are general questions in the sense what is this costume and what is the classes, why like this, general question. Many maximum most of the questions are related to that one. That is the reason, instead of asking, so if I take one general class to discuss, so it is good, right? So it will be helpful for the remaining students, those who are joining again and again. No, so if I'm telling to them, those who are there in the class, so they will get bored by listening same answer again and again. That is the reason. So I may so in few of the comments I may not respond. Due to that reason only I didn't respond. So if you feel sorry for it, definitely, so I'm accepting that one, I can understand, but the flow should not disturb, right? That is the reason I didn't answer. Now anyway, every day after class around, if it is completed 12, definitely 12. If it is, sometimes it may complete 11:20, 11:30, like that. That time you can join it. Yes, I'll take. So you can contact to this number 984981280. This is my number. You can contact to this number. Okay. So further details we'll discuss. Right. Okay. So now I'm going to 12 exactly. Now 12 p.m. We'll talk with Seva sir. Every day this session. Why I'm taking this session means, so people who are coming new, they'll be having many doubts. Many doubts. Sir, why this sir is like this? What is this costume? Why it is happening like this? So what is the reason behind of this? What is the motive? Why classes are like this? Okay, and the timings, everything. There are many doubts, many doubts. So yeah, it is just now. It is almost 2 hours. So continuously talking, standing. Okay. So then fine. So come and join at 12 p.m. Thank you so much for joining and attending. So join at 12 p.m. Talk with Siva sir. So be like that only. I'll come and join. Hello, hi everyone. So, welcome to the live class again. So, Anonymous, hi. Hello, Akash. Do you teach even in offline? So, yes. So, any details you can contact the number. So, so this is the number. So, you can check. You can contact this number and mention WhatsApp number is there. WhatsApp only. WhatsApp only. It has WhatsApp. Okay. So, on this number, WhatsApp is there. You can contact. You can message. Yeah, definitely. So, grade 10. Which class you are looking for? Which classes you are looking? So let me know the and I already given the number, right? You can contact to that number. We'll discuss. Yeah, definitely. You can contact to this number. So I'll explain. Physics. Subject physics. Thank you, Anonymous. So resistance, just now I explained, no? So just before only before ending. I hope you right. Just now only came. Resistance is the phenomena of opposing the electric current. Resistivity is equal to resistance of the conductor per unit length and unit cross sectional area. Is it clear? Hi Bhattacharya, how are you? Welcome to the class. So you'll join exactly this time, yeah, every day. R equal to rho into L by A, rho equal to RA by L. Thank you so much. So your name, how to pronounce your name? Oh, thank you so much. Thank you so much. Oh, thank you so much. Thank you, Kohinoor. Okay, Bhattacharya, 36 out of 40, great. Until 1 o'clock, until 1 o'clock classes are there. Sorry, Ranu Thakur, thank you so much. I'm happy to see the messages, comments. I am okay, fine. So we are in self doubt and pressure. Okay, don't worry. So everything will goes according to the time. So no need to worry about it. Be confident and do what is necessary. That's enough. Chat Mr. Above. Everything is fine. So I uploaded videos also in YouTube. So here you can see related to physics, not only physics, remaining subjects also, remaining subject like maths, uh, chemistry, biology, social, English, and remaining any subject tuitions if you want. If you need classes, you can contact to that number. I already pinned it. I already pinned it. I already pinned it. Okay, Bhattacharya, carry on. So I already pinned it 9849812804. So that is a number. So WhatsApp is there on that number. You can contact that number for any classes. So any subject. So physics, including physics, right from physics. Okay. So physics to remaining subjects also if you want classes, if you need tuition, so you can contact to that number. So mention your name and okay. So you can contact which grade you are. Then we'll discuss further details. Hello, Atlantis. User ID Atlantis. Hi. So this is almost 3 hours. Almost 3 hours live session. Great. So you can call, no problem. So to the given number, you can call and let me know regarding your details, which classes you need or everything. So further details we'll discuss. Yes, I will give online classes only. Which class? Vujan Mukhopadhyay, 10F S3. Class 10. Okay, done. You can contact to that number. WhatsApp is there on that number. You can contact to me. So we'll discuss regarding the classes. Mention our name and mention your class. WhatsApp is there. You can contact on that number. WhatsApp. Okay, you can send WhatsApp. Then after seeing that one, because number of calls I'm getting, right, that's the reason. So if I see in WhatsApp, then slowly I will respond to your messages. So better you can send WhatsApp. Okay, so WhatsApp message, right? So those who have remaining, so remaining subjects, not only physics, remaining subject like maths, chemistry, English, social, so remaining languages. So if you need any classes, any tuitions, you can contact to that number. You can contact to that number. So I had a great team. So minimum 5 to 10 years experience people are there. So more than that also it is there. I am speaking in English only, right? So those who need classes, again I'm saying those who need classes, right? Check once. So BTech which subject? Subject. So remaining students, those who are there in online, so you can contact to that number for remaining subjects. So physics, maths, chemistry, biology, social. It's okay, fine. I already asked, right? Same question. Which is subject? Subjects. Jessica, hi. Jessica, in the previous class also you joined and said the answer, right? Like 10 ohm or something. You only. What happened, Arpit? So I remembered you. Oh, thank you. Thank you so much. Hello, Sir Belugu. Hi, hi. Yeah, you are back. Sir जी रेस्ट का टाइम रेस्ट करो प्लीज. Oh, thank you. Thank you so much. What can you like that? Sir, please answer whether you teach. Ujjan, I'm saying to you only. Okay. I'm saying to you only, Ujjan. I'll take definitely. Actually. Oh, thank you, Jessica. So thank you so much. So it's almost 1 p.m. So every day it will be 1 p.m. sleeping time. Morning time around 5, 5, 6, around that time generally. Hmm. Yeah, of course. Yeah, maths का teacher हो. Something I am fan of your singing style. Okay. Someone said maths का teacher हो. Why you sleep? Okay, so only 9 minutes left. So I'm not a math teacher, so I'm physics teacher. I'll teach physics. So those who are new to the channel, do like, share, and subscribe to Student the Brand. And you can watch my videos. You can watch my videos in the YouTube channel playlist. So you'll get to know. So all the methods of teaching and anything, everything. Methods of and different topics and different kinds of teaching. So we'll see the kinds and types of teaching. How many types like that? So there are many. So you can watch my videos. You'll get to know. Yeah, thank you so much. Hard work is necessary. It's not about compromising. So it's about enough sleep for body to do great work. If you want to do anything, of course, passion. More than that. So only 7 minutes left. 7 minutes left. So you reverse it that question. So to teach 4 hours, to teach 14 hours, I'll sleep 4 hours. To teach 14 hours healthy and active manner, I'll sleep 4 hours, 4 to 5 hours, not too much time. So 6 more minutes. Those you have any questions, you can ask. See in the class there are so many questions. So continuously like a floating. So I couldn't able to answer because see now this time I will utilize for answering the questions. Then everyone will get to know. Even the person who is asking for them, it's like a if it is a right way. At the same time, we'll get some time to speak. That's the reason I'm taking this session. So on everyday basis, like if the on the particular day if they have any questions related to concept, the motto is my motto is on the day why I'm taking this class to clarify the doubts on the particular subject. Aishwarya, thank you so much. So you didn't join today class, right? So in previous classes you attended previous classes. Sleep is indeed important, sir. Okay, done. Sure, I'll take it as a suggestion and advice. Definitely, I'll follow. You need more students to teach. Reach out to many. Okay. Of course, me also very excited. So for everything whatever you want to do, so definitely will be having time. So just you have to manage the time. That's enough. Everyone has only 24 hours. So according to utilization, it depends. According to works, how you manage your time, it depends. Okay, 2 more minutes. So after 2 more minutes, I'm going to end the live session. So thank you so much for joining and attending and interacting with me. Uh, Thank you very much. So not that much, but okay, 2 more minutes. I hope those who are there in line. Thank you so much for joining and attending and making the live class very interactive manner. So I'm happy to see you all. Thank you so much. I'm very clear. Oh. So maybe okay. So thank you so much. So signing off. We'll see in the next class. Okay, class timings. So once again, I'll remind the class timings: 11 a.m., 3 p.m., 6 p.m., and 9 p.m. So see you soon. Thank you.